February, March 2017, paper 3, variant 2. Question 1. State a part of the graph that shows the car at rest. Okay. The car at rest. This is a speed time graph. Okay. Speed time graph. الcar at rest would be at لا C is not at rest. C is not at rest. It's either A or E طبعا A or E. Okay. طيب state a part of the graph which shows the car moving at a constant speed. طبعا yes الناس قاعدة بتقول C. okay أنا I will um, okay yes طبعا definitely it's at C. During the part of the journey when the car is decelerating, calculate the distance traveled. How can I find the distance traveled while decelerating? يلا. Decelerating speed time graph. I need to find the distance. How can I find the distance يا شباب? Area under the graph. صح؟ يلا. What's the area under the graph? Area under the graph. Area under the graph part of decelerating is الحتة دي. Yes. When I don't know
هنعمل
what's wrong.
half times 16 times 8.
Okay. Half times base times height, which is half times 16. Yes, the height is 16. And the base is 8. From 20 to
8.
28, it is 8. صح. يبقى half times 16 times 8. Half times base times height is half times 16 times 8, which is 64 meters. Correct. طيب. Another car accelerates from rest starting at time 0. The car has a constant acceleration. Its speed, okay, its speed at 20 seconds is what is 10 meters per second. Its speed at 20 seconds is 10 meters per second. Why is it 16 and 8? Again, the previous question, why is it 16 8? Half times base times height. The height of this triangle, he said while decelerating. So I'm talking about this triangle alone. The height is 16 and the base is from 20 to 28. This is the base from 20 to 28. 28 minus 8 is 8 and the height is 16 from 0 all the way to 16 above. Okay? طيب. Another car, okay? Another car starts from 0. Okay? Another car starts to accelerate from 0 and reaches a speed of 10 meters per second after how many seconds? After 20 seconds. Reaches a speed of what? Of 20 sorry, of 10 meters per second after 20 seconds. So after 20, where's 20 seconds? This is 20 seconds. After 20 seconds, it reaches a speed of 10. Where's 10? At this point. This is 10 at this point. What should I do? I should draw a straight line from 0 and 0. Yes, that's it. I should draw a straight line from 0, 0 all the way to 20 seconds and 10. This is 10 meters per second. That's it. Okay? That's all you need to draw. Describe using figure 1.1. How can you decide which car has the greater acceleration? Which car should have the greater acceleration يا شباب? Which car should have the greater acceleration? The car with the greater slope. The car with the greater slope. صح. Someone said B, which is correct. B is the correct answer. Why is B the correct answer? Because it has a greater slope. يقول هنا car B. Okay, أو section B, whatever. It's the same car basically. I can say section B or the first car. Again, you can say either section B or you say the first car. Why? Because it has the greater slope. Okay, section B or the first car. Why? Because it has the greater slope or greater gradient. Okay. Okay. um ماشي. ايه عندك؟ ثانية. Okay. What's your question?
ممكن يا مستر نقولها steepest gradient.
أيوة steeper gradient. It's all the same.
تمام.
Okay. Yeah. Next question. I have reading K and reading L. I have a measuring cylinder, reading K and reading L. Reading L is for the balance. Then I have reading M and reading N. Use the labels K, L, and M to find the mass and to find the volume. How can I find the mass of the stone? How can I find the mass of the stone? It's very simple. I need to find this reading, which is the mass, the second mass minus the initial mass. N minus L. N minus L. The volume of the stone would be V2 minus V1, which is M minus K. صح؟ M minus K. بس خلاص الموضوع. It's that simple. M minus K. Okay? I guess it's quite easy. The student obtained the following values, mass and the volume. He wants to find the density. How can I find the density? Density equals mass over volume. طبعا. Density equals mass over volume. Mass 78. Volume 30. 78 divided by 30. I guess تبقى 2 point something. 78 divided by 30 is 2.6. Definitely the unit. Okay. 2.6. Do not forget the unit. What is the unit? Grams per centimeter cubed. Yes. Volume, grams per centimeter. If it was kilograms and meter cubed, it would have been kilograms per centimeter cubed. Quite easy. Any problems? Any questions up till now? Okay, good. Do we have to change it to kilograms? لا, we don't. لا, we will leave it as grams. Grams per centimeters cubed. Okay. Next question. Have a beam which is balanced on a pivot. Explain the meaning of center of mass. Center of mass is one of the definitions which we usually tend to forget. Okay. Center of mass, it's a point. Okay. It is a point at which all of the weight or all of the mass, okay, tends to act or seems to act or acts. You can just say acts. Okay. Is all of the mass, for example, okay, the center of mass of this beam, okay, behaves, maybe behaves, it's not wrong, okay, it's not wrong, okay, or seems to behave, okay. Again, the center of mass is at this point, okay, which is at almost the center of the beam. It's a point at which all of the mass, I'll write it down, a point at which, okay, all of the mass seems or it's as if it acts at this point, okay? Seems to act. Why am I saying seems to act? Because not all of the mass, definitely not all of the mass is at this point. The mass is distributed throughout the whole beam. It's distributed throughout the whole object. But the center of mass, it's as if, I'm saying it's as if the whole weight or the whole mass is acting at this point. Okay, the whole mass or the whole weight acts at this point. Okay, and it's a very critical, crucial point. It's really important. ماشي. Moving on to the next question. Calculate the distance x from the pivot. The beam is balanced. Once I say that the beam is balanced, it's in equilibrium. What do I mean by equilibrium? Again, clockwise equals anti-clockwise. We have to write down clockwise moment equals anti-clockwise moment. Clockwise moment equals anti-clockwise moment. This load will turn the beam this way, and this load 1.5 will turn the beam the other way. clockwise. The clock rotates in this direction. So the 1.5 load is the one causing the clockwise moment, and the 2.5 load is the one causing the anti-clockwise moment. How do I calculate moment? Force times perpendicular distance, and on the other side, force times perpendicular distance. Force times perpendicular distance on the clockwise moment is 1.5 times the distance x. I do not know distance x. No, I don't know the distance x. Anti-clockwise moment is 2.5 times 2.5 times 18. 2.5 times times 18. Can I calculate it? Yes, quite easy. Yeah, 2.5 times 18 is what? 2.5 times 18 is 45. 45. هنا 1.5 times x is 45. How can I find x? I'll do is divide. I will divide 45 divided by 1.5. 45 divided by 1.5 is 30 centimeters. Okay, it's a very simple equation. Very simple equation. Just need to understand that we have clockwise moment and anti-clockwise moment. For it to be balanced, for it to be in equilibrium, the clockwise must be equal to the anti-clockwise moment. ماشي. Calculate the mass of the 2.5 load. How can I find the mass يا شباب? We know weight equals mg. Weight equals mg. What should I do? I need the mass, so it's equal to weight over g. 2.5 divided by 9.8. Okay, 2.5 divided by 9.8. What's 2.5 divided by 9.8? It would be around 0.255. Okay, 0.255 kilograms, correct. Okay, we're using 9.8 يا شباب. Even though this is an old exam, it's an old test, but we will use 9.8 to make sure that we memorize it. Okay, yeah. We can round, maybe, yeah, we can round 0.26. Wouldn't be wrong. Okay. Any questions? Yeah, please, if you have any questions, don't hesitate to ask. State the name of the process that releases energy in the nuclear reactor. Okay, in the nuclear reactor. It's one of the forgotten processes. Usually we tend to forget this process. Okay, do you remember it?
nuclear fission تقريبا.
Fission, yes, thank you. Nuclear, not fusion. Okay, nuclear fission. Okay, nuclear fission. Okay, fusion, nuclear fusion happens in the sun. Nuclear fusion happens in the sun. But in the nuclear reactors here on Earth, we use what? We use the nuclear fission. Suggest a suitable radioactive material for the fuel rods. Radioactive material. Okay, someone said uranium. Okay, good. Okay, it's the most popular fuel we use in the nuclear reactors. Uranium, or sometimes we use something called plutonium. Below are some statements we need to write them down in the correct order. J, K, L, and M. Do I have to write 200? No, you don't have to write. You can just write down uranium. That's it. That's enough. In the correct order, the generator produces electricity. I think producing the electricity is the last one. Right? It should be the last one. The energy is used to boil the water. Okay, the nuclei split, releasing energy. Okay, the steam drives a turbine. Okay, it's quite obvious that L. Okay, a lot of you have said that L is the first one, which is correct. Yes, L. And then the energy is used. Okay, nuclei splits, releasing energy. Take this energy to boil water. Correct. K. L then K. And then when you use this energy to boil the water, what do I do to the water? It turns into steam. Okay. And then it's quite obvious that finally, the generator will produce some electricity. Okay, correct. The nuclear reactor is contained in a very thick concrete casing. Suggest why? Someone said it's very, very dangerous. You have an answer? To prevent leakage because it can be toxic. Okay. Okay. Any answers? You have an answer?
To prevent the escape of any ionizing radiations.
To prevent the escape of any ionizing radiations. Okay, they're all correct. Okay. Again, it is very dangerous. Yes, definitely. We have to state two marks. Okay, 2 marks. We have to state first of all that it is very dangerous. Okay, it is very dangerous, and we need to protect. Okay, to protect from any escaping radiation. Okay, all of the radiation that is produced in the reactor is very dangerous. It could cause cancer, could cause mutations. Okay, to protect from leaks. Okay, you're all correct. Gamma radiation to escape. Okay, protect humans. Okay, you're all correct. So just one advantage and one disadvantage of a nuclear power station compared with a wind turbine. One advantage and one disadvantage. Nuclear power station compared to a wind turbine. How can we compare them both? Someone said higher energy output. Okay. What else? Low initial cost. Save fossil, not noisy, reliable, non-renewable. Okay. Advantage is more reliable. Okay. One advantage is definitely not polluting. Okay. When I'm comparing advantage, one disadvantage of a nuclear reactor to a wind turbine, not polluting, not polluting. Disadvantage. Okay. Um, it is reliable. Yes, it is reliable. When I'm comparing them both, it is reliable. Why? Because it doesn't depend on the wind. If it depends on the wind, for example, like the wind turbine depends on the wind. Some days we can have a lot of wind, some days we won't. So it wouldn't give the same energy output. So it's not reliable. Okay. Expensive. We don't need to go into too much details about the cost. Noisy disadvantage. A disadvantage of the wind turbine is that it is noisy. Yes. Disadvantage of the wind turbine is that it is noisy. Okay. One disadvantage is the nuclear waste. Yes, thank you. Okay. The nuclear waste. It's a huge disadvantage for the nuclear power stations. Non-renewable. Okay, you can say non-renewable. It's not wrong. Okay. Non-renewable. Yes. Okay. Wind turbines use renewable source of energy. State the name of another renewable source of energy. We have so many other renewable sources of energy. Okay. You can't say wind again. No, it was he said wind. You can't say another wind again. Solar energy. Okay. Tidal energy. Waves energy. Hydroelectric. Geothermal. Okay. Solar. Or you can say geothermal. You have a lot of them. But try to avoid saying wind again. Okay. Advantage that there is no pollution. Um, no pollution. Well, both of them are kind of polluting. يعني let's try to avoid saying that the advantage that there is no pollution. Okay. Okay. Um, noisy in the advantage of the nuclear. No, 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 no. Don't write noisy. Do not write noisy. Okay. Yep. Moving on to the next question. Not noisy. Uh, maybe. Not. Okay. Next question. Calculate the pressure. Pressure equals. We know the pressure. Pressure equals what? Hmm. Force over area. We have the force 6,500 divided by the area, which is 100. This will give me a total pressure of 65 newtons per centimeter squared. A farmer cuts the bottom of one of the posts and makes it more pointed. The bucket applies the same force. Explain the effect this has on the pressure exerted by the post on the ground. How does this pressure differ? How is it different? Is it greater? Is it less? Is it the same? Definitely, we'll say that it is. قول لي كده. It is
بريشر بقى جريتر علشان السيرفيس
okay.
اريا كده.
Increased pressure. Okay, correct. Since the surface area decreases, عشان pressure equals force over area. As the area decreases, the pressure decreases. Okay, correct. Or vice versa. As the surface area decreases, the pressure increases. Weight distributed to the whole body. لا, no, wrong. No. Condensation, then the second one is called, it was liquid, it became gas, which is quite obvious. You can say evaporation or boiling. Both of them are correct. Boiling or evaporation, it is correct. From liquid to solid, definitely this is freezing or evaporation. Solidification, I mean. You can say freezing or solidification, and definitely from solid to liquid is حلو, melting. Okay. Some gas is heated at a constant pressure. You have some gas. I'll heat this gas at a constant pressure. Describe what happens to the molecules of gas as the temperature increases. When the temperature starts to increase, what happens to the molecules of the gas? They move faster. They gain kinetic energy. And they move faster. Okay. More frequent collisions with the walls. Okay, that's not wrong. Okay. Okay. And when I say constant pressure, move faster, you have to say that the distance of the volume increases. Okay. Volume increases. Or the distance between the molecules increases. Volume increases, pressure no, pressure does not decrease. Pressure is constant. Pressure is constant. When you increase the temperature, what happens? Thermal expansion. When you increase the temperature, what happens? Thermal expansion. So the molecules move further apart. That's it. The molecules start to move further apart. Okay? Oh. When the metal bar when the metal bar expands, okay? It's when it's heated, it expands. What happens? Definitely all of them increase. Definitely. Length, width, and height, the whole volume increases. State one use and one disadvantage of thermal expansion. One use and one disadvantage of thermal expansion. Okay, one use is okay.
اليوز ممكن يكون الميتال ستريبس.
Okay,
الديسادفانتج اللي هو الايرون ريلويز buckling.
okay. Buckling of train tracks. Okay, and the use is the thermometer, correct? Okay. I have a wave. The wave transfers what? definitely the wave transfers energy. The number of waves per second. Number of waves per second is frequency, huh? What's the problem, يا جماعة? Hell, thermometer. The use is thermometer, and disadvantage is the buckling of train tracks. Well, thermometer and train tracks. A number of waves per second is the frequency. The distance between P and Q. Distance between P and Q. P and Q هنا. What's the distance? This is the amplitude. Yes, bravo. It is the amplitude. Between Q and R. Q and R. This is the trough and this is the trough. So distance is the wavelength. Bravo عليكم. Yes, bravo. Yes. Seems like you've been studying. Okay, I'm really proud of you all. The wave on the string is an example of a transverse wave. Explain how transverse waves differ from longitudinal waves. How are they different? Transverse waves and longitudinal waves. Transverse. اوكي قول لي كده. Yes, perpendicular.
انا برضو انا استفزيت من الميل
Transverse
وبعد
travel
كده
perpendicular to the energy motion.
Okay. A transverse is definitely up and down. Okay. Transverse travels. Okay. A wave travels up and down, perpendicular, صح, perpendicular to the energy motion. Longitudinal travels left and right parallel to the energy motion. Okay, good. حلو. Do I have to say up and down? Yes, you have to say up and down. Okay. You don't have to say that it contains, oh, it has crests and troughs. Okay. Next question. People on a container see the flash before they hear the bang. They see the flash before they hear the bang. قولي لي كده. Why?
عشان light travels faster than sound.
Correct. Correct. Because light travels faster than sound. Don't just say that the light travels fast. Okay, it travels faster than sound. Okay. People on the container ship hear two bangs. They hear the second bang shortly after the first bang. Explain why they hear two bangs. Why do I hear two bangs? Okay, it is يلا. Okay, ماشي. You're saying correct. قول لي كده.
عشان الايكو ريفلكشن.
Echo reflection from the echo or the reflection. Okay, from the cliff. You have to state that it reflects from the cliff. Okay, correct. Okay, echo or reflection from the cliff, bro. Yes. Yeah, next question. The speed of the sound in air is 330. The firework explodes at a distance of 1 kilometer from the container ship. Calculate the time taken for the first bang to reach the people on the container ship. Okay, this is a very simple speed equals distance over time equation. Okay, it's a very simple speed equals distance over time in which we can rearrange them to find, we know speed equals distance over time. We need to rearrange it to find the time equals distance over speed. Distance over speed. The distance is now 1 kilometer. Should I just write down 1 kilometer?
هنعمل 1 times 1000 تبقى 10
Times
meters.
1000 to change it to meters. Thank you. Okay, so it has to be 1000 meters divided by the speed, which is 330. This would give me a time of 3.03 seconds. Okay, 3.03 seconds. Right. Estimate the time delay between hearing the first bang and the second bang. Okay, I heard the first bang after 3.03 seconds. The second bang most probably would take double the time. Double the time. So if you say 6.06, that's right. It is right because it's double the time. Okay. Any questions? Jeb, do you have any questions? Do not hesitate, please. Do not hesitate to ask. Okay, yeah. Yeah. Now we have how is thermal energy transferred throughout the water? Okay, inside the water, how does it transfer? We need to use our ideas about density and expansion. Definitely, this is called what it is called convection. 5 marks. Okay, we have 5 marks. Yeah. Convection. What happens in the convection as the water gains kinetic energy? As the molecules gain kinetic energy, what happens? The distances between them increases. The distance between them increases. When the distance between them increases, what happens? The volume increases. When the volume increases, دلوقتي الvolume increases, يبقى density, what happens to density? Density decreases. Density decreases. Again, when the density decreases, you have to say the hot water. If you ever say that the heat rises, that's wrong. Okay? That's definitely wrong. Probably you'll, يعني, if I were the examiner, I would have failed you the whole test. Okay? What should I say? I have to say the hot water. If it was air, for example, I would have said the hot air. Okay? Whatever fluid I'm talking about. The hot water in this example, hot water moves up. Hot water moves up, and the cold water falls down or moves down or whatever. Okay, cold water moves down. You have to state that the cold molecules, the hot molecules. Um, okay. Hello. Any questions? Yeah. Any questions? Yeah. Next question. Determine the angle of incidence at mirror A. Okay. Determine the angle of incidence at mirror A. 60? What? Why is it 60? Why is it 60? Hmm. Sure. The angle of incidence has to be 70. Why is it 70? This is the normal. صح? No, this is the normal. Angle of incidence is always between the incident ray and the normal. This is the angle of incidence. We're not gonna measure it. We're not gonna measure it. We're just going to calculate it. How will I calculate it? 90 minus 20. 90 minus 20 is 70 degrees. Okay? 90 minus 70, 90 minus 20 is 70 degrees. Okay? Um, yeah. Next question. The ray is also reflected from mirror B. On figure 10.1, continue the path of the ray until it is reflected from mirror B. And then use letter R to label the angle of reflection from mirror B. Okay? Initially, I will continue this line. You have to continue this line until it reaches mirror B. At this point, you have to draw a normal. At this point, you have to draw a normal. Okay? This is the angle of incidence. If you measure this angle of incidence, it should be 20. If you measure this angle of incidence, it should be 20 degrees. When you measure this angle of incidence, it would be 20 degrees. What will I do? I will do a reflected angle back inside, definitely, because this is reflection. This angle of incidence is 20 as well. He said label this angle of reflection, I'm sorry. He said label the angle of reflection R. So this is the angle of this is the reflected angle, which is also 20. 20 angle of incidence, 20 angle of reflection. That's it. It's as simple as that. Okay? Okay. Yeah. State the law used to complete the ray diagram. I equals R. Correct. Angle of incidence. We don't have many laws. We don't have many rules in this unit. Angle of incidence equals angle of reflection, or you can just say I equals R. That's it. Okay, good. Hmm. Any questions, please? If you have any questions, please don't hesitate to ask. Okay? Yep. ماشي. Next question. Okay. State the material from which an electrical conductor can be made, and a material from which the electrical conductor, probably copper. Yes, copper is correct. Don't just say metal. Okay, don't just say metal. You need to state the type of metal. Okay, you need to state the type of metal. It would be copper, which would be much better. Center zero meter matches the electromotive force across the conductor. State the unit of EMF. Yes, EMF is okay. EMF is volts or V. Okay, volts or V. Okay, yeah. State which what if anything happens, okay? Um if it moves horizontally, starts to move horizontally between the poles, starts to move in this direction, left and right. What will happen? Can someone tell me what will happen? Hmm. Hmm. Yeah, nothing will happen. Correct. Correct. Okay. يلا ثانية واحدة. Okay. Okay. Yeah, definitely nothing will happen. It will no deflection. You can say no deflection or nothing will happen. Nothing or no deflection. Why? Why? Because the electrical conductor is now moving along the magnetic field. This is the South Pole and this is the North Pole. If I'm moving with the direction of the magnetic field, where's the direction of the magnetic field? Okay, where is the direction of the magnetic field? If I, okay, remove this one. Okay, the direction of the magnetic field is always from the North Pole to the South Pole. So if I move the wire along the direction from north to south, wherever the north and south is, if you move the wire along the direction from the north to the south, no current will be induced in the wire. But if you move it up and down, as in the next question, if you start to move it vertically, up and down, whenever I move it vertically up and down, what will happen? It will start to produce a current. It will start to induce. What do I mean by induced current? It means that I will generate a current. So vertically up and down between the poles, what will happen to the center 0 meter? It will, yes, definitely, it will deflect to, okay, left and right, to the left, okay, and right. So it produces current only vertically. Yes, in this case, it produces the current only vertically. Okay, if you cut, that's the whole point of cutting the magnetic field. If you move along the magnetic field, if you move with the magnetic field, then it will not produce a current. But as long as you're cutting, you're moving perpendicularly to the magnetic field, then you can produce a current. Okay, you can induce a current. State two factors that affect the size of the EMF. State two factors that affect the size of the EMF. Any ideas? Okay. Current is wrong, resistance is wrong. If you say strength, okay, on its own, it's wrong. Uh, okay, strength of the magnetic field. Okay,
Strength of magnetic field.
what else? Strength,
Amount of coils.
number of turns in the wire. Okay, I need واحدة كمان. Okay, one even better. There's how come you forgot it? Strength of the magnetic field. Magnetic field, and the last one. And the last one is
The speed of moving.
speed of the motion. Okay. Okay. Motion or whatever. The speed. You cannot say the current. Why? You cannot say increase the, why? Because in this case, I am producing the current. I am inducing, I am generating the current. You cannot say increase the current in this case. If you say increase, it's wrong. Okay, it is wrong. You have to say either. Okay, either increase the magnetic field or increase the speed. Definitely, if you had turns in the wire, you can increase the number of turns. But since you have only one wire, that's why I didn't want to say it. Okay, you have only one wire, so you wouldn't be able to increase the number of turns in the wire. You wouldn't be able to increase the number of turns in the wire. Okay, but definitely, if you say current, it is wrong. Okay. This question is about the structure of atom. We know the charge. I guess we all know the charges. What's the tell me. Particle, the first
أول حاجة
particle,
neutrons,
neutron, and then
protons,
proton, and then
electrons.
electron. This is quite easy. 3 very easy marks. Draw a label diagram to show the structure of a lithium atom Li 7 and 3. How should I draw the lithium atom? A lithium atom is very simple. To draw a lithium atom, it is very simple. What should I do? All I need to do is draw a nucleus. Inside the nucleus, I need some protons and some neutrons. And then outside the nucleus, I need some electrons. That's it. You do not need to draw, for example, electron cloud. You don't need to draw the first shell and the second shell and the 2 electrons in the first shell and 1 electron in the second shell. I don't care about that. I do not care about that. I'm physics. Okay. This is a physics test. It's not a chemistry test. All I care about in the physics, very simply, I need a nucleus. In this nucleus, I need 3 protons. So P, and then 4 neutrons, and I'll state that this is the nucleus. And then I have 3 electrons outside the nucleus, and that's it. N neutron, P proton, and E electron, and that's it. Okay. Good.